The generic rectangle is review of chapter 3, but we'll be using it for the next couple of days. So the highlighted text says in chapter 3, we learned how to multiply algebraic expressions using algebra tiles and generic rectangles. This section will focus on reversing this process. How can you find the product when given the sum? So just as a reminder of what we did in chapter 3, I'll do 2 examples. If you see the tiles like this, the ones that are matching lengths, like a Y, this is an XY tile, a Y, so the other ones will continue that. And then this is an X squared tile, so these are X's. And the reason we have what's called an XY tile is because we have an X multiplied by a Y. Any of the skinny dimensions are 1s because 1 times Y makes a Y tile. The reason we have an X squared tile is because X squared is X multiplied by another X makes X squared. So you're just thinking about what are its outside lengths and widths. I've got a long skinny one that's an X, and all these single tiles are just 1s. And that helps you to put the 1s on the outside as well. And the long ones are Y's and X's. So the way that we write our answer as a product is we look at what is this outside length and width. So we have a Y tile, an X tile, and 2 singles. And then on the other side, we have an X tile and 4 singles. The way that we write our answer as a sum is we list all the tiles that we saw inside the whole thing. So there's one XY tile, cross it off. There are 1, 2, 3, 4 Y tiles, so plus 4 Y tiles. And then there is an X squared plus 1X squared. There's 1, 2, 3, 4 X tiles plus 4 X tiles. Oh, nope, there's more than that. There's 2 more over here as well. So we actually have to say that there are 6 X tiles. And lastly, there are 1, 2, 3, 4, 5, 6, 7, 8 ones, so 8. I'm not going to ask you to do this on the test, but we need to remember this rectangle shape to help us do the rest of the problems for this chapter. So question B says, use the generic rectangle to multiply 6x minus 1 times 3x plus 2. So as a reminder, you make a rectangle with 4 sections. On the outside, one of the lengths is going to say 6x and minus 1. The other outside side length will say 3x plus 2. It doesn't matter which one you put on the bottom and which one you put on the side. Then we're making a multiplication chart. I'm multiplying the 3x by 6x, and that makes 18x squared, because 3 times 6 is 18, and x multiplied by another x is x squared. Continuing with our multiplication chart, we would likewise still have this 3x being multiplied by minus 1. So 3x times a negative 1 is negative 3x. Then on the top row, we have 2 multiplied by the 6x, and then 2 multiplied by the minus 1. So 2 times 6x will be 12x, and 2 times negative 1 is negative 2. Almost always, the diagonal ones here are like terms that we can combine, and so we write our answer as a sum. We say that we have an 18x squared tile, we have a minus 2 tile, and then we have these ones that we can combine, the 12x minus 3x. So 12 minus 3 is 9x's. And this is my answer of what happens when I multiply those together, and then list out the pieces as a sum. Next, we're going to work backwards and do the opposite. The pieces of the multiplication are shown, but we don't know what it started as. So if I look at problem A, as a sum, that just means listing the tiles shown. There is a 6x squared tile, there is a 5 tile, and I can combine these ones because they're both x's. 2x and 5x is 17x. To write it as a product, we have to figure out what it would have been on the outsides that got multiplied into this. It's called looking for a common factor. So for example, these two going up and down, 6x and 2x, they both have an x in them and they both can be divided by 2. So this number on the outside should be a 2x. And 15x and 5 both can be divided by 5, or I can take a 5 out of them. So the number that goes on the outside is 5. Then we look at what did I need to multiply by to get there. So to get to the 6, the x would have had to be multiplied by 3x. And that works all the way across. 3x multiplied by 5 would also make 15x. And for the top one, 2x times 1 is 2x, and 1 times the 5 on the bottom is 5. So my product is listing these outside dimensions, 2x plus 5 and 3x plus 1. I will do one more, and you'll have to do the last one by yourself. So we're looking for what is a common factor. Let's see if I go up and down first. Both of these have a y in them, and 2 and 5 don't have a number that they can both be divided by, so the only thing they have in common is y. -6 and 15x can both be divided by 3. So the common factor is 3. And if I go the other direction, the y and the 3 can both have been multiplied by 5x. And if we multiply that, it will create each of these numbers. And then the y would need to have been multiplied by -2, and the 3 also multiplied by -2 would make -6. So to write it as a product, we list what we see on the outside of our dimensions. Y plus 3 multiplied by 5x minus 2. The order does not matter as long as you have them grouped with the parentheses. And the sum is just listing the tiles that you see. There's a 5x squared or a 5xy tile plus a minus 2y tile plus a 15x and plus or minus a 6x tile. You'll try the last one on your own, writing it as a sum and as a product before you turn in the assignment. Last thing we need to learn for today is that there is actually a pattern to these rectangle problems, and it has to do with the diagonal. If you multiply this diagonal that's circled there, 6x squared and times 5, that makes 30x squared. And if you multiply the other diagonal direction, 2x times 15x, that also makes 30x squared. And that's not a coincidence. That will happen on every diamond problem. I can check the one below it. $12x squared times -12 is -144x squared. And -9x times 16x is also -144x squared. The reason this pattern matters is it helps us figure out what's missing. I'll do the first one, you'll have to do the second one and finish the rest of the assignment. So I know if I multiply this diagonal, 6x squared times 5, that's 30x squared. So that means the other diagonal, 5x times something, has to also make 30x squared. 30. So 5x times what makes 30x squared? 5 times 6 is 30, and to go from x to x squared, it would also need to have an x. So the piece that's missing is 6x. Go to the next one. You try multiplying the diagonals and see if you can figure out what number is missing in the question mark. For number 6, you have to look for what are those common numbers that you can take out, find out what would be the outside length and width, and write them in parentheses. And lastly, problem 7, you will have to make the generic rectangle and multiply in the 4x minus 1 on one side and 3x plus 5 on the other. Multiply them out and list what the sum is at the end.